In this video, we derive the quadratic formula by completing the square in the general case. We want to solve the general quadratic equation ax squared plus bx plus c equals 0, where a is not 0. The point of solving this equation step by step to derive the formula is to show how such formulas are found. There's no need to memorize the solution, just aim to understand each step as it is presented. We start with the given equation. Since we're going to complete the square, we subtract the constant term from both sides of the equation. Now, since completing the square requires having a leading coefficient of 1, we divide both sides of the equation by the non-zero value a. Now we take half of the coefficient of x, square it, and add the square to both sides. This is the general process for completing the square. It produces a perfect square, x plus b over 2a quantity squared, on the left-hand side of the equation. On the right-hand side of the equation, we need common denominators to add fractions. After multiplying the first fraction by a clever 1, we add and simplify on the right-hand side of the equation. Then we take the principal square root of both sides of the equation. Notice on the right-hand side of the equation, we've also used the quotient rule for radicals to square root the top of the fraction and square root the bottom of the fraction. Taking the square root of perfect squares produces absolute values. The absolute value produces plus or minus. Notice that one set of plus minus takes care of both absolute values in the equation. Finally, we add a negative b over 2a on both sides to get that x equals minus b over 2a plus or minus the square root of b squared minus 4ac, also over 2a. We combine those two separate fractions and write it as one fraction with a common denominator. Minus b plus or minus the square root of b squared minus 4ac all over 2a. It might be a good idea to pause here and review each step for yourself with the goal of understanding what occurred. If you are baffled about this derivation, you can always move on and return to this video when you are ready.